So the mass of a black hole depends on the type of black hole. They can be as small as 10 of our suns, or they could be as large as billions of our suns, okay? And when I say large, I'm talking about mass. So not the size, like not volume, but kind of how much stuff is there, how much matter is there. Okay, so black holes, they have a lot of mass compared to little itty bitty Earth. So think about, right, our sun and our solar system, right? Like I just said, there could be 10 suns worth of mass in a black hole. There could be 1,000, or there could be 10 billion, the mass of 10 billion suns. So a whole lot of mass. Right? So we have a lot of mass there. And the thing about black holes is they're not very large. They're actually very tiny. So you're taking all that mass and crunching it down into a tiny space. So think about all of those suns and then squishing them, crunching them into like the space that's the size of a pencil tip. Okay, that's basically what a black hole is. It's a whole bunch of mass that is compressed into a tiny space. That's kind of crazy. Okay, so here we have, right, our picture of how things with mass, they make space-time bend, right? Okay, so black holes, if they're even more massive than a star like our sun, they can bend space a lot more. So this is showing maybe how much our sun would bend space. This is what a black hole does. Okay, so again, this is just showing how much more mass a black hole has. It's so massive that it really, really bends space-time. And you can see how it's easy for things to fall into it then if it's so deep. All right, so what is a black hole? It's an object with a lot of mass that bends space into a very small point. Okay. This picture is just showing that, you know, if a star gets too close to the black hole, it'll basically either be thrown, it could be ripped apart and go inside. Okay, so it just depends on how close that thing gets to the black hole. All right, so where do these black holes come from? Did they just appear in our universe? No, they have to come from somewhere, right? So here's what we think. We believe that black holes come from dead stars. Basically, after a star dies, it can become a black hole. All right, so stars, they live, right? They're burning up fuel, creating heat. That's when they're alive. Once they run out of stuff to burn, then something else happens to them. And it depends on what their mass is. So just like people can have different paths in life, stars can also have different paths. If you have a small star that only has a little bit of mass, it will turn into a white dwarf at the end of its life. That's just another type of star. Okay, if you have a star that has a little more mass, a medium amount of mass, that's like our sun, eventually, over billions of years, it will turn into what we call a red giant. So it'll swell up and it'll actually change color into more of a reddish color. And then eventually it'll shrink back down again and become a white dwarf. If you have a star that has a lot of mass, so a large mass star, it will also become a red giant. But then instead of turning into a white dwarf, it explodes. Okay, so this is what we call a supernova, when the star explodes. And after it explodes, it can either become what we call a neutron star, or it can become a black hole. So only the biggest of stars become black holes after they die. Okay, so why do they come from stars? That's weird, right? Imagine a star, and when it's alive, there's all these atoms, this hydrogen gas that's moving around inside of the star, and it's getting very hot. So all that heat, right, it is a bunch of energy that's inside the star. Okay, so all those gases, those atoms that are moving around inside, they're actually putting pressure from the inside of the star, and they're pushing the star outwards, so like keeping it big. Think about maybe a balloon, right? If you blow air into a balloon, that's going to make it expand because you're putting pressure from inside the balloon. A star is the same thing. There's gases in there and they're pushing outwards, okay? But at the same time, the force of gravity is always trying to pull that star back into the center. So you have these two forces, the pushing outwards of the gas and the gravity pulling inwards at the same time. And when the star is alive, these two are kind of balancing each other out. So the star is staying the same size. It's not really getting huge. It's not getting small. It's just staying the same size when it's alive. Okay, but eventually the star runs out of things to burn inside. So what do you think happens when a star runs out of fuel? What happens when it runs out of the energy that is pushing outwards here in the center?